Hello, everyone. It's your teacher Ray here. Today, I'm bringing you a simple question from the latest sample exam for mathematical methods. As we know, this year, the curriculum has updated. So we'll go through the examples from the vcaa before the final exam comes, can help us build a closer understanding with the real exam for the incoming test. And the question I selected today is about functions, graphs, and calculus. The calculus is a main study area for the mathematical methods exams. And go through the extended response question. It's very, very important that we extract the useful information from the whole long exam question informations. So Jack and Jill have built a ramp for their toy car. They will release the car at the top of the ramp and the car will jump off the ramp. The cross-section of the ramp is modeled by the function f, where we are given a piecewise function, or AKA the hybrid function. So this given function is separated by two parts. First is a horizontal constant function, the y equal to 40, between x greater or equal to 0, less than 5. And then we have a curve, and x is greater or equal to 5, less or equal to 55. And fx is both smooth and continuous at x equal to 5. That is very important. That means at the moment when x equal to 5, for the derivative of the first part of the function is exactly as the derivative of the second part of the function. So we are not having like a substitute x equal to 5 for the first derivative, for the left part, the derivative is different as the right part. The graph of y equal to fx is shown below, where x is a horizontal distance from the start of the ramp and y is the height of the ramp. All lengths are in centimeters. And first, find out the f dash x, the first derivative for x greater than 0, less than 55. So student may consider that it's very easy, right? We have the expression here. However, the function given to you, the curved part, is just between x greater or equal to 5, less than x equal to 55. So you must find out both of them. So the first part is as a horizontal constant function, the gradient or the derivative is equal to 0. It's very easy. And next part, as it is exam 2, do not waste the time on work it out by hand. Use your CAS, define this function, and use the manual calculus and the first one derivative. Work it out the derivative. 1 over 800 times 3x squared minus 150x plus 675. And as a function, not just the relation, the expressions, but also the domain. So the first part of the domain, x is what? Is less than 5, but now greater than 0, because, watch that. The question just asked the domain between 0 to 55 exclusive. So do not use the original domain, like including the 0. And also, x greater or equal to 5. Sorry, less than 55. It is 2 mark. It is the introduction of the question. However, some of the students lost the mark. Second, B. So find the coordinate of the point of inflection of f. In the chapter 10, we discussed the shape of the graph and the second derivative of the function. The first derivative defines the strictly increasing, strictly decreasing, the stationary point, and the second derivative defines, is it a concave up, is it a concave down, or do we have? The point of inflection. Look, just the point of inflection. So how we find out the point of inflection? We make the second derivative equal to 0. Solve this equation and we can work it out. X should be 25. And after that, we are not stopped because we're looking for the coordinate. So you must also work it out what is F25 equal to. So this kind of process sometimes would tripping you, all right? You should understand what is the first step, second derivative. After you solve the equations, have the X value, you should substitute back to the original function, which is F25 equal to 20. So the coordinate, all right, the point of inflection is the 25 and 20. All right, 25, 20. It is 1 mark, but it's ready to get it. All right, second one. So find the interval for x which the gradient function of the ramp is strictly increasing. Look, do not be too excited, all right? The question is asking for the strictly increasing for the gradient function. Look, the question even kindly highlighted the important term. So we are not looking for the original function. We are not looking for the fx where we are strictly increasing. We are looking for the derivative, the f dash x strictly increasing. So if we're looking for the f dash x strictly increasing, we can just observe it. All right, the f dash x is a quadratic function, right? So left, and it is also a upright, like open to that side. So left side of the turning point, it is going down, and right side of the turning point, it is going up. And then our interval for the straightly increasing, that would be 25 goes to 55 inclusive. All right, and then for the strictly decreasing, that would be the 5 to 25, both inclusive. These three tiny questions, it was a 3 mark, but very, very, very easy to get caught. All right. So just be vigilant and careful when you read and do the questions. Jack and Jill decided to use 2 trapezial supports, each with 10 centimeter. The first support has its left edge placed at x equal to 5, and second placed at left edge at x equal to 15. Their cross-section are as shown in the graph below. Determine the value of the ratio of the area of the trapezial cross-section to the exact area, all right, exact area contained by between fx and x-axis between x equal to 5 and x equal to 25. Give your answer as a percentage, correct to 1 decimal places. So first thing first, you need to find out the exact area enclosed by the curve, the x equal to 5, x equal to 25, and x-axis, all right? So you use your cast from the 5 to 25, fx dx, work out the definite integral, all right? And you would have your answer is equal to 650. All right, leave it aside. And also we need to find out the trapezial cross section. How many trapezium we have here? 2 of them, right? So each of them would be the half times the height times the sum of the top and the bottom, the top and bottom, the base size, all right? So for the first one, that would be the 40 plus F15, all right? And then for the second one, we would have half times 10 times the F15 plus F25. And then you can use your cast, work it out your area. And that is equal to 637.5, all right? And we're looking for the ratio, so we do not have to care about the unit during work it out questions, all right? Because finally we have the ratio, no unit, just a ratio. And finally, we need ratio is the the exact area and the trapezial cross-section like approximate versus the exact. So that would be the 637.5 out of 650. You have to multiply 100% because question looking for a percentage, and then round to 1 decimal places. So actually, if you do the divisions between the two numbers, you're looking for correct to 3 decimal places. And finally, the answer would be 98.1%. All right, 98.1%. All good? All right, the D part. Referring to the gradient of the curve, explain why the trapezium rule approximation would be greater than the actual cross-section area for any interval between x belongs to P and Q, where P is greater than 25. Look, for the previously, we can obviously see the exact area is larger than the approximation because the curve is above. However, the question is actually asking to prove when x greater than 25, the exact area is smaller than the approximation, which means our curve is underneath. What is the shape? What's the name of this kind of shape? We call it. It is concave arc. How to prove concave arc? Please, we should prove that when x equal to when x is greater than 25, the second derivative is a positive. So at this moment, it is concave arc. All right. So you can just repeat it, the sentence. That's it. It's 1 mark, but you have to provide the reason and the statement clearly. Jack and Jill roll the toy car down the ramp and the car jumps off the end of the ramp. The path of the car is modeled by the function P, where we have now further discussions. For between 0 to 55, we have the rotate as the fx. And when x greater than 55, less or equal to a, we have another function, which is negative x squared out of 16 and then plus bx plus c. And x equal to a is where the car lands on the ground after the jump. So at that moment, our y value is equal to 0. Find the values of b and c. So by the given information, right? First thing first, it is a continuous and smooth curve. So continuous means our f55 is equal to the g55. Even though x equal to 55 is not in the domain of g, however, it is smooth. So we are not having a gap between the graph, right? And second, as it is smooth, we should have the derivative when x equal to 55, and they are equal to each other to substitute the different part of the functions. And then you would find out simultaneous equations related to the variable b and c, and then you can solve it. All right, so after you substitute, after you simplify the equations, you can solve it. So the b is equal to 8.75 and c is equal to negative 283.4375. Question tells you to round to how many decimal places. So you have to provide exact answers. And luckily, both of them are exact answers, although you have the c value 4 decimal places. The E2, all right? Determine the horizontal distance from the end of the ramp to where the car lands. Gave your answers in centimeters, corrected 2 decimal places. Now, the question asking the distance between the end of the ramp. Look, end of the ramp is where x equal to 55, not x equal to 0. Some students may confuse like, what is x equal to 0? That is a start of the ramp, right? That's the start of the ramp. So end of the ramp is x equal to 55. And then we need to find out where the car lands on the ground, which is the y value equal to 0 when x equal to a, and you have to make g a equal to 0 to work it out the answer. All right, and also you should have a is greater than 55. So if you have because it is a quadratic equation, you may have more than one solution, and you have to use the given information to discard the inappropriate solutions. So finally, a should about 89.10 because we round to 2 decimal places and 1 0, not just a 1. All right, so final answer, we should have 89.10 minus 55 and 34.10 centimeter. That is the final answer, the distance between end of the ramp to the moment car lands on the ground and in the unit. So when you can have the unit, not the ratios, not the things like others, you have to provide your unit at the end. Thanks a lot. It is approaching to our final exams and just a couple months left. So please do not just focus on what we are learning and we will learn incoming. You please should also focus and put effort on prepare your boundary note and the previous knowledge, especially for the circular functions, the algebra, the graphs, and the basic knowledge about functions, and also the geometry. Thanks a lot. Very appreciate attend my tuition weekly classes. If you like that, you can contact with our admin and follow us on the public account, the WeChat, the Little Red Book, YouTube, and Facebook. Thanks a lot, and see you next time.